The second method of traverse adjustment is referred to as the compass rule. Now, the compass rule is also known as or referred to as the Bowditch rule in honor of the American navigator Nathaniel Bowditch. Okay. The compass rule is based on the assumption that all lengths were measured with equal care and all angles taken with approximately the same precision. It is also assumed that the errors in the measurement are accidental and that the total error in any side of the traverse is directly proportional to the length of the traverse. Okay, so the error is directly proportional to the entire length of the traverse. We employ the following formulas, no, in applying compass rule. C1 refers to the correction for any course, or CL, no, small letter L. C sub small letter L is equal to C sub capital letter L D all over D. No? Where CL refers to the correction to be applied to the latitude of any particular course. No? So CL, that is the correction to the latitude for any course. No? So for line 1 or line AB or whatever, we denote it by C sub L. No? And then CL refers to the misclosure in latitude. Misclosure in latitude. Now D refers to the length of the course. So if it is line AB or line 1 or whatever. And D refers to the total length of the traverse. Or it is the entire perimeter. Okay, so this formula is simply based on ratio and proportion. Okay, the correction for latitude of any course is to the total latitude correction, as the length of that course is to the total length of the traverse or the total perimeter. Corollary to this is the correction due to departure, which is equal to C sub capital letter D for the misclosure and departure multiplied by the length of that course divided by the perimeter. So in here, our C sub D is the correction to the departure. Correction to the departure for any course. And then C sub capital D, that is the misclosure in departure. Right? After we have calculated for the individual correction for the latitudes and the departures, how do we then apply these corrections? So for example, your misclosure in latitude is positive. This indicates that there are more positive latitudes than there are negative latitudes. Okay, so the correction, say CL1, will be negative of the sign or opposite to the sign of the misclosure in latitude. No? In that way, positive latitudes will diminish in value, while that of negative latitudes will increase negatively. Okay. Um, Same thing, if the misclosure in latitude is negative, that means that there are more negative latitudes than there are positive latitude. So the correction that we are going to apply should be positive. In that way, the negative latitudes will diminish in value, while the positive latitudes will increase in value. So we apply the same rule for the corrections to be applied for the departures. Now, after adjusting, no, we shall refer to the adjusted latitude as lat prime of, say, line AB, and the adjusted departure as depth prime of the line, say, AB. Once we have adjusted the latitudes and the departures, we can then adjust the length, and we shall refer to it as L prime, which is equal to, of course, we have to apply Pythagorean theorem. That will be lat prime of the course squared plus depth prime of the course squared. And for the bearing or the angle, theta prime, it will be arctangent of depth prime of the course over latitude prime of the course. Okay? Let us now work on the following problem. So given below are the observed distances and bearings of the lines of a closed traverse. We do the following. Calculate the latitude and departure of the lines, and then we have to determine the misclosure in the departures and the latitudes for us to be able to adjust the traverse using the compass rule. And once we have adjusted the latitudes and the departures, next thing to do is to adjust the distances and the bearings. All right. So first thing first, we have to calculate for the latitudes and the departure. So latitude and departure. Again, what is our formula for the latitude? The latitude is equal to the distance times cosine of the angle, and the departure is equal to the distance multiplied by sine of the bearing or the azimuth. So for line AB, the latitude of line AB is 495.85 cosine of 5 degrees and 30 minutes. That is 493.57. The departure, on the other hand, is 495.85 sine of 5 degrees and 30 minutes, and that is 47.53. And they are both positive since the line is in the northeasterly direction. So we can tabulate it now for 93.57 and 47.53. We'll be doing the same thing, no, for the other traverse lines. So in here for line BC, it is 590.53, and then the departure is 612.23. So you can check the entries, no, using your calculators. So for line CD, the latitude will be negative 325.53, while for the departure it is positive 791.09. We now go to line DE. We'll be getting negative 996.99, and the departure is still positive at 219.51. Then for line EF, the latitude will be negative because it is in a southerly direction, 121.96. West direction, so the departure should be negative 1110.58. Finally, the latitude of line FA being north is positive 377.19. No? So you can indicate the sign whether it is positive or negative. Then departure to the last line is negative 541.70. Alright? So we are done with problem 1, that is latitude and departure of each line. So the next thing that we should do is to get the misclosure. Now, before we can adjust, we need to determine the misclosure. So your CL is equal to the summation of all the latitudes. So that will be 493.57 plus and so on and so forth plus 377.19, and that must add up to positive 16.81 meters. So the magnitude 16.81 is what acceptable because the distances involved are quite large, no? So 495, the longest being more than a kilometer, 1,100. So it is understandable why we have a large misclosure in latitude. So it is positive. No? There are more positive latitudes than there are negative latitudes. So you can check that by just adding all the latitudes. So for the departure, that will be the summation of the departures equal to 47.53 plus and so on and so forth up to negative 541.70. And the misclosure in the departure is also positive 18.08 meters. Again, you can check these values. No? You can add the latitudes and the departures and then you check these values for the misclosures of the latitude and the departure. Okay? Now remember in our formula for the correction, for the latitude correction CL, we shall be needing the total latitude correction multiplied by the ratio d all over d. Alright? D all over d. So we need to find the total distance. And what is the total distance? So we add up distance AB, distance BC, up to distance FA. So that is 495.85 plus and so on and so forth up to 660.08. And so that will give us a value of 5,000.13. So you can verify that by adding all these distances. Okay? Now that we have the total perimeter or the total distance, we can start calculating for the corrections. The corrections for the latitudes and the departures. So let me write here. Latitude correction. So we can start at CL of line AB. That should give us the total misclosure in latitude times distance of AB all over the total distance. So the common fixture here is CL all over D multiplied by the distance AB. Okay? So CL of AB is equal to the total closure in latitude 16.81 divided by the total distance of 5,000.13 multiplied by the distance of AB 495.85, and that should give us 1.67 meters. Okay, so for the next line, CL of BC, we'll be using the same factor. So let us call that as asterisk. So it's just asterisk times the distance of BC, which is equal to 850.62, and that must equal 2.86. Again, you can check these values now by using your calculator. So we can do that for the rest. CL of CD, CL of DE, CL of EF, and CL of FA. You should get the following values of, let me see, 2.88, 3.43, 3.75, and 2.22. So let us check the sum. No? So 7, 13, 21, 24, 29, 29, 31, 3, 9, 17, 25, 29, 36, 38, 3, 4, 5, 6, 7, 8, 9, 10, 16.81. 16.81. Yes, that is the total. So we can tabulate these values. So the correction for the latitude. Corrections for the latitude. Remember, it should be negative, no? It should be the negative of the value that we will get here. We have a net positive, so the correction should all be negative. Negative 1.67, 2.86, 2.88, 3.43, 3.75, and 2.22. Alright? Next, we calculate for the departure corrections. Departure corrections. So the correction for the departure is equal to the total departure correction, distance of the course to the total perimeter. So for CD of line AB, that will be the total 18.08 all over the total distance of 5,000.13 meters, okay, multiplied by the distance of AB. So 1808 over 5,000.13, distance AB again is 495.85, and that should give us 1.79. So correction with departure of line BC will again be, well, we have this factor again. You can call it as double asterisk, no? Multiplied by 49. The next one, BC, is 850. 850.62. And that should give me 3.08. Then repeat that for line CD, for line DE, line EF, and line FA. And the values that you should get are 3.09, 3.69, 4.04, and 2.39. So let us check. Let us add 9, 17, 26. What is this? 69? Yeah, okay. Again, 9, 9, 9, 27, 36, 40. Let me check that. 9, 9, 9, 9, 36, 48. Okay, 48. 4, 11, 17, 20, 2, 3, 6, 9, 12, 16, 18.08. Is that correct? Yes, no? 18.08. So we tabulate these values under the heading of departure. So, the departure, total misclosure and departure is positive, so the correction should be opposite to that, negative. That will be negative 1.79, negative 3.08, negative 3.09, negative 3.69, negative 4.04, and negative 2.39. Okay. So, we need to adjust now the latitudes and the departures because we know the corrections to be applied. So, latitude, adjusted latitude and departure. So, for line AB, 493.57 minus 1.67. Okay? So, that should be 491.90. Okay? Next, 590.53 minus 2.86. That should be 587.67. Next, negative 325.53 minus 2.83. That is negative 328.41. Next, negative 996.99 minus 3.43. That must be negative 1,000.42. Then negative 121.96 and negative 3.75 is negative 125.71. Then 377 minus 2.22 gives us 374.97. Okay? And you can check that. They should add up to 0. For the departures, AB 47.53 minus 1.79 is 45.74. Next, 612.28 minus 3.08 is 609.15. 791.09 minus 3.09 is 788. 219.51 minus 3.69 is 215.82. Negative 1110.58 minus 4.04 is negative 1114.62. Finally, negative 541.70 minus 2.39 is 544.71. Okay, again, you can check that and the sum should be equal to 0. I think it is 5. No, this should be 544.09. Okay, let me check. 9, 10, 11. And that should be negative. 971. 9, 11 carrying 1, 9, 7. Okay, that's correct. So, those are the adjusted latitudes and departures. So we are done, no? The second one. Finally, we have to adjust the distances and the bearings. So the adjusted latitudes are L prime and the adjusted departures are dep prime. Okay? So the lengths, how do we find the length? The adjusted length. The adjusted length is simply equal to the square root of the adjusted latitude squared, adjusted departure squared. Okay? So, the adjusted length of line AB will be equal to the square root of latitude of AB is 491.90 squared plus adjusted departure is 45.74 squared. Okay? And that should give us how much? For AB, it should be 494.02. 494.02. And we apply the same formulas for the other traverse lines. Okay? So adjusted length, adjusted distance or length. We write it again. Okay, adjusted distance. That will be 494.02. For the adjusted length of BC, it will be 580 square root of 587.67 squared plus 609.15 squared. And that should give us 846.42. Then line CD is the square root of quantity negative 328.41 squared plus 788 squared, which should give us 853.73. Then we do that for the three remaining lines, and we should be getting the values of 1,023.43, 1,121.69, and 660.78. How about for the adjusted bearings? So the adjusted bearings will be denoted by alpha prime. And the adjusted bearing, so alpha prime is equal to arctangent of the adjusted departure over the adjusted latitude. So alpha of AB, that will be arctangent of departure adjusted of AB, 45.74. Okay, this one, divided by 491.90. 491.90. And that should be 5 degrees 19 minutes. 5 minutes and 19 minutes. And what is the direction? Northeast. Okay? So we do that for the other five lines, no? For adjusted bearing of line BC, it will be arctangent of 609.15 all over 587.67. And we should be getting 46. Okay, let me tabulate first the adjusted bearing of AB north, 5 degrees and 19 minutes east. For BC, it is 46 degrees 02 minutes northeast also. For CD, it is 67.23 in the direction southeast. Then 12 degrees 10 minutes, direction southeast for line DE. Then 83.34 in the direction southwest for line EF. And finally, for FA, it is 55.26 in the direction northwest. Alright? So, those are the adjusted distances and bearings. Okay? You can also calculate for the linear error closure based on the misclosure in latitude and the misclosure in the departure. Okay?